That's recorded now. Okay, are you ready to pay attention or no? Tell me. Ready, everyone, to pay attention? Okay. Okay. Yes or no? Okay, it's important that you pay attention, right? Okay, because this is the complicated part. Now, the mathematical induction. The mathematical induction have two steps. The base step, okay, normally as you prove, o sea, when I put equal, it's okay, because the statement one, so for n equal 1, I try to prove. Remember, our expression, okay, want to prove contain left-hand side, right-hand side, no? Left-hand side, right-hand side, left-hand side, equal right-hand side. So are you evaluating 1? Because we are working with the natural number, no? 1, 2, 3, 4, 5, no 0. It's starting 1. You prove that this statement is true for n equal 1. Entonces, the stupid thing is continue 2, 3, 4, 5. No. You assume, suppose. Okay, llame. You assume, you suppose, que one arbitrary k, que es intermediate value, k is intermediate between 1 and m. But n is infinity. Okay, intermediate. It's true. This is supposition. Entonces, under this supposition, using an example right now, using algebra, basic algebra, elementary algebra, you prove x, this supposition imply, this arrow indicate imply means cause effect. It's true. See, both conditions, the red one and the blue one is true, you can conclude okay, the next one is also true, and this situation continues forever for k plus 2 plus 3 and to infinity. And the super fantastic conclusion is the statement is valid for all real numbers. All real numbers, no, sorry, all natural numbers. Remember, we are talking about like a sequence. A sequence is the function, but the domain is natural number. Okay, this is the idea. The justification this is a little bit beyond the scope of this class. This is, see, some people need to take discrete mathematics and you take logic, you understand a little bit more better this. However, I bring one video. Okay, I would like you watching that video. This is not my video, it's a YouTube video. Okay, I find. Let me see. Share. Switching to the video. Okay, this video on YouTube. Do you see the video now? I want to play now. Okay, good. Well, okay, the audio. Okay, this is funny. This is to understand the intuitive idea for the mathematical induction.
Professor, I can't hear. There's no sound.
You say get frozen? Do you say get frozen? No sound. Why? I put too loudly, but it's okay. It's okay. Okay, don't worry for this. This is just funny. Let's move on to the example. Well, one possibility is I share in the link. I send the link with the video, no, to our lecture. I send also the link of this video. Okay, this is one solution. Always we try to find solutions. Okay, solution. Do you see the whiteboard now or no? Yes. No? A ver, let me see, Jasmine. Okay. Wait. No, whiteboard. Okay. Okay. Oh, yes. You're right. All right. Okay. Well. Okay, there you go. I suppose que in this moment you see very well the whiteboard. Correct? Jasmine? Good. Okay. So remember, in the last class, I put example. Oh, okay. I put example like that. Look, I want to prove. Use mathematical induction, of course. Que 1 plus 3 plus 5 plus 7 plus that. In general, the A sub m explicit expression for the, because actually this is the odd number, no? Is 20 minus 1. So you, for example, you evaluate 1, n equal 1, 2 times 1 is 2, minus 1 is 1, and 2 times 2 is 4, minus 1 is 3. So this is expressed A sub m. It should be equal n squared. I need to prove this using mathematical induction. No? So now, let's go to the basic step. Basic step. I try to prove that x1 is true. And x1 is evaluated at n equal 1. At n equal 1. In the left-hand side, we have just 1. In the right-hand side, we have 1 squared. It's 1. This is true. Okay, stop now. I go to the inductive step. In your solution, you don't need to write that. This is for only purpose of the explanation. No? You assume that A sub k is true. Okay, I enforce the situation. I assume it's true. In other words, I write again my problem: 1 plus 3 plus 5 plus 7. This is 2k minus 1. Put the parenthesis, oh no, it's not important. Equal k squared. So the only thing I did was replace n for k. I assume that this is true. Okay, now I try to, this is a sub k. I try to manipulate a sub k plus 1, que is the next one. Because the next one is exactly the same. I want to copy again. 1 plus 3 plus 5 plus 7 plus 2k minus 1. And you include the next after 2k minus 1, que is 2k plus 1 minus 1. So you replace the next, see this is k for k, the next is 2 times k plus 1 minus 1. This is the left hand side. And the right hand side we have replace k plus 1 squared. Do you understand this step? That's too easy, eh? Too easy, eh? So you understand this? We almost finished. Okay, good, Yamin. Therefore, remember the assumption was that part is k squared. Do you remember that? This is this. Entonces now I apply distributive property here. This is 2k plus 2 minus 1, no? The basic is k squared plus 2k plus 1. And when you expand or factorization, it doesn't matter. This is k squared, square first plus twice, multiplication both, plus 1. And you get through. So the idea is clear. The idea was you assume that this is true, and you prove that the implication of this define k plus 1 is true. If it is true, this continues forever like a piece of domino. Okay, I want to illustrate in the video. Do you understand the idea? You see it's no big deal. It's relatively easy. Okay, entonces basically es assume que a sub k is true, proof algebraically que x plus 1 is x sub k imply que x plus 1 is true, and this continues forever. Any question? Confusing? Clear? Come on, opinion. Clear. Jasmine dice clear. It's okay. Everyone follow me? Okay, let's move on to another more interesting example. Look at another example I like so much because I sort of understand. O sea, a sort of understand means you understand a little bit or you understand full. Sean? A little bit. Okay. I understand. I understand you. This is the first time I saw in my life this idea. I don't understand very well. Suppose this. This is a formula that we are using last class. Que es the sum of the first natural number, no? Que we using this famous formula. I suppose you remember that, right? Entonces now, let's prove using mathematical induction that formula. Okay, remember the step. You prove that S1 is true. X1 in the left hand side is just 1. And the right hand side is 1 plus 1 divided by 2. 1 plus 1 is 2, divided by 2 is 1, times 1 is 1. It's true. Now I assume that A sub k is true. I enforce this situation. Because I know that under this condition, see, I prove that A sub k imply A sub k plus 1. Remember, cause and effect. This process continues forever. So I only thing to do is copy exactly the same. But you put no M, you put K. Under the consideration K is intermediate value, no? In the line of the domino piece. Okay, the domino piece is natural number. Now, this is true. I assume that this is true. So now I try to write xk plus 1. It's easy because the only thing you should do is when I copy 1 plus 2 plus 3 plus plus k plus the next case k plus 1. I put a parenthesis or no, it doesn't matter. Include the next. in the left. In the right also, no? In the right is k plus 1. Because this is a k, you replace k for k plus 1. Entonces this is k plus 2, no? Because it's k plus 1 divided by 2. Okay? But I know that part under this assumption is k plus 1 over 2 plus k plus 1 should be equal this expression. That's it. Let's do it. Well, so I propose you condensing everything in one common denominator, que es 2. So we have k plus 1 plus 2 times this, que es 2k plus 2. Entonces, for a moment, I manipulate only the left-hand side. Let's see. Now you distribute the property here. It's k squared plus k plus 2k plus 2 over 2. Okay, almost I finish. Because you combine like term. It's k squared plus 3k plus 2 over 2. Okay. Okay, let me try to manipulate now the right-hand side. Well, right-hand side is super easy. Not necessarily do anything here. You FOIL. K squared. Yeah. Here. K squared. You FOIL. K squared. 2k. 1k. And 2. Divided by 2. And finally, we combine like term. Wow, and we get identity. Something equals something. It's true. Therefore, this process continues forever for all real numbers. Do you think it's no big deal? It's easy or relatively easy. Any question? It's clear or no? Opinion. It's clear. Yasmin says it's clear. Sean, much better now? Yeah, I got it. Okay. One more or no? Clear. One more or no? One more problem or no? What do you think? Yes. Yasmin says, please, yes. Okay. One more. Let's see the famous formula that we are using in the last class. When this is summation, remember summation. Let me change the color. Summation, we studied that formula in the last class. Summation for I want to call I equal 1 to m. And is it I squared? Remember, we can use any variable here. It's totally dummy variable. It's equal m plus 1 to m plus 1 divided by 6. In conclusion, I use a summation notation, but actually this is 1 squared plus 2 squared plus 3 squared plus plus m squared is equal m plus 1 to m plus 1 divided by 6. I need to prove that using mathematical induction. So I try to prove x1 statement is the first guy, get 1 squared, that by the way is 1. In the right hand side we have 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6. This is 2, this is 3, 2 times 3 times 1 is 6 divided by 6 is 1. It's true. So when you get, suppose that x1 is not true, it's false. You try with the 2 until you get 1 true. So not necessarily always the basic step corresponded with the 1. In this case, yes. Okay, nice. I like that. Now, I go to the inductive step. In the inductive step, it says, okay, you assume it's true. 1 squared plus 2 squared plus 3 squared plus bam 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 k squared is equal k times k plus 1 to k plus 1 divided by 6. I assume that this statement is true. He will be able to prove that the next one is x plus k. So this implies that this is true. Entonces now this continues forever. Okay, entonces I put 1 squared, 2 squared, 3 squared, plus k squared, and the next is k plus 1. The next is k plus 1 squared. K plus 1 squared. In the right hand side, well, on the right hand side we have now k plus 1. K plus 1 actually is k plus 2. And 2k plus 1 is, it's complicated. Look, it's 2k plus 1 plus 1, no? Because you replace k for k plus 1. Entonces 2k plus 2 plus 1. Ahora es k, 2k plus 3 divided by 6. I need to prove that. But under the consideration that this guy is equal k plus 1, 2k plus 1 over 6. It was the assumption that we are doing in the first part. Okay, and the rest is just algebra. And the rest is just algebra. Let me try to do my best. I want to change the color because I feel much better with the black color. K plus 1, 2k plus 1, 6 divided by 6 plus k plus 1 square. Okay. What should I do? Well, you condensing. Least common denominator is 6. Es 6. Entonces 6 es k plus 1, 2k plus 1, plus 6 times k plus 1 squared. Well, I can see, for example, there are many ways to continue. However, I can see that k plus 1 is a great common factor. I factor out k plus 1. Look here, 1 time, and here 2 times. No? So we have, look in the bracket, we have k, we have 2k plus 1, and we have 6k plus 1, only 1 time, divided by 6. Okay, now after that, why not distribute the property and combine later. So we have 2k squared plus 2k plus 6k plus 6. Okay, over 6. Now finally combine later. So we have k plus 1, paréntesis, why not? 2k squared plus 8, no? Plus 8 or plus 7? Wait. This is not 2. Mistake here. 2k squared, this is k times 1 es k. Entonces 1k and 6k es 7k plus 6. Super. Divided by 6. We continue manipulation. Maybe yes, maybe no. I don't know. Okay, let's go now to the other side. On the other side, well. We, for example, I copy here. I manipulate this in order to look like similar to this or equal. So I propose you, for example, k plus 1, because I can see something similar. This is similar to this. Look. Entonces I foil this. Entonces I copy k plus 1. You foil. Is 2k squared plus 3k. K times 3 is 3k, no? 2 times 2 is 4k. 4k. Plus 6, no? 2 times 3 is 6. Over 6. Okay. Now combine later. K plus 1. 2k squared plus 7k plus 6. Wow. Everything divided by 6. Entonces it's true. And we prove. Okay, this is the little bit magic, eh? Entonces now, of course, you don't need to prove in the real life. Pero suppose okay, we have another weird identity, and this is a fantastic way to prove that. Any question? Any question? In the review packet, we have another. Here in the test, we have another. Okay, it's very, very similar. Everything okay, guys? Enough? You understand the basic idea? Of course, you need to practice, no? This is logical. You have to practice. Okay, so let's switching now to another topic. Okay, by the way, it's the last topic. It's a super easy topic. Okay, it's the binomial theorem. Binomial theorem. Binomial theorem. Binomial theorem, guys, you need to know very well in calculus. Okay, we're using, not every day, but we're using sometime. What is the idea? What is the idea? What is the idea? Newton discovered the binomial theorem when they have 18 years old. He is a genius, no? What is the idea for the binomial theorem? Okay, I need to find that formula. Look, a plus b, a binomial, two term, raised to the n power. What is the general formula? To get the formula, I want using the induction, but no mathematical induction, using like a deductive. Okay, I try to, for example, at n equals 0, the particular case at n equal 1, and so on, and try to see what is the regularity of the formula and try to find the formula. Suppose it's 0, a plus a to the 0 power 1. Yeah, I want to put this one here. You see why. Now, a plus 1, a plus b, sorry, raised to the first power, que es n equal 1, is just a plus b. And I want to put here, look, this coefficient is 1, and this coefficient is also 1. Yeah, I put it here. Look, 1. I'll try to make a contraction, a special contraction here. N equal to, bueno, es a plus b square. And you know, okay, when you FOIL, this is a square plus twice ab plus b squared. And I put these coefficients, okay, 1, 2, and 1 here. 1, 2, and 1. Do you follow me? Everyone follow me? I try to discover the formula of the Newton. Okay. I want to complicate more this. Now suppose n equal 3. Suppose n equal 3. Es a plus b cubic. Well, this is a long process. I want to skip the algebra part. You trust to me, okay, I'm doing well, no? So suppose que you multiplication a plus b squared. Wow. I live near the air base. Entonces, suppose que you multiplication a plus b squared, que es this answer, times a plus b again. And we get this result. Look, let me show you. A cubic plus 3 a square b plus 3 algebra, no? AB squared plus BQ. Y I copy the coefficients, que es 1, 3, 3, y es 1. Okay, I need to organization in this pyramid. Actually, it's no pyramid, it's a triangle, the coefficients. Suppose n equal 4. Now multiplication again, a plus b cubic times a plus b to the 1 power, and you get a to the 4 power a cubic b plus 6 a squared b squared plus 4 ab cubic plus b4. Yeah, I copy the coefficients. Look at that. 1, 4, 6, 4, and 1. Okay, one more to the 5th power and stop, because I realize very well where's the mathematical low. This is 4 power. Sorry, I make a mistake here. This is 4 power. It's logical, right? It's 4. It's n equal 4. Now to the 5th power is a to the 5th power plus 5. A to the 4 power b plus 10 a cubic b cubic plus 10 a squared b cubic plus 5 a b4 plus b5. I copy the coefficients. Es 1, es 5, es 10, es 10 again, repetition, 5 and 1. Okay, stop. So I see the regular. The regular is Cn, for example, Fi, we have 6 elements. 1, 2, 3, 4, 5, and 6. One more. Entonces, my formula, the formula que Newton discovered, expressed like a summation notation. Look, expressed like a summation notation. Start, for example, this is totally dummy. K0, I assume que K0 is the first guy, 2m. So in between 0 and n, actually we have n plus 1 term. Okay, suppose this is K0, this is K1, 2, 3, 4, and 5. Que n represent the exponent of the binomial. Entonces I see one number, but one number que I have no idea. Well, I have idea because I organize here in this is the Pascal triangle. Okay, I want to discover the regular and the formula also to find that. And you have A, okay, is the first letter, look, raised to the n minus k. Remember, k represents the index of the summation symbol. Okay, at the beginning k is 0, so it's m. So así es to the 5th power, 5 here. This is m. This is m. And the second exponent is minus 1, because k is 1, or k is 2, or k is 3, or k is 4, or k is 5. If 5 minus 5 is 0. That is the reason que the last guy do not depending of A. And B to the K. Wow, the exponent was easy identification using induction. Several particular examples give me the general formula. We can prove using mathematical induction. Well, of course you can, but it's too long. Now, entonces, what is the rule? Well, the rule, look in the Pascal, you see that, for example, one element here is the sum of this and this. 1 plus 1 is 2. ¿Es coincidencia? No, it's a fact. Look, this 4 is 1 plus 3. This 6 is 3 plus 3. This is the rule. Suppose this, remember, this was n0. This was n1. This was n2. This was n3. This was n4. This was n5. And what about n6? Let's do it. And it's easy. It's 1. Here, look, this diagonal is 1, 1, 1, 1, 1, and it's a 1, 1, 1, 1. It's super easy. This is 6, 1 plus 5. This is 15, 5 plus 10. This is 20, 10 plus 10. This is 15 again, repetition, 6 and 1. You see it's symmetric, you know? We have one number in the middle, and this is repeated symmetrically here. Okay. But okay. That's it? No, because Newton discovered more. Discovering that this coefficient we can express mathematical, no graphical in the Pascal triangle. Discover que can express like a combinatory number. Combinatory numbers. And the combinatory number, the notation for the combinatory number look like that. Parenthesis NK. So what is the formula for the combinatory number? Well, the formula for the combinatory number is combinatory number NK is equal n factorial divided by k factorial multiplication by n minus k factorial. I suppose you remember factorial. You remember or you don't remember factorial? See, I don't remember, I refresh your memory. For example, let's practice that number, no? That number is 10, no? Combinatory number 5, que es the exponent, and the index is 2. Is 5 factorial divided by 2 factorial and 5 minus 2 factorial. Factorial is, for example, 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is, well, is 2 and 1. It's just 2. In this case, a particular example. And 5 minus 2 is 3 factorial. And 3 factorial is 3 times 2 times 1. Entonces now, for example, to finish this part, we can, for example, we have 5 factorial divided by 2 factorial that we discovered que es just 2, and 3 factorial is, well, is 3 times 2 times 1. However, I recommend that you expand 5 factorial to 3 factorial, que es the bigger number in the bottom. Entonces, 4 times 3 factorial. And you have 3 factorial, no necessary expanding because cancel out 3 factorial and 3 factorial. And 5 times 4 is 20. 20 divided by 2 is 10. And this 10 is this 10. Do you understand the idea or no? A little bit clear. Entonces I propose Jasmine and the rest of the students. I propose start the review for the test 5. Pero let me start. Okay, you understand, Sean. Let me start. So let me get the part related with the binomial theorem. For example, let's do in the question 17. So now I propose start doing the review for the test 5. And remember the test 5 is due April 28, next Wednesday, no? Entonces let's do review. This is a review. Pero review we are doing no for the question 1, 2, 3, 4, 5. No. Review for the test 5. We are doing backward. So let's do in the part que corresponde with the binomial theorem. Let's use in this. Is 2x plus 3, no? To the 5th power. So the question say expand this binomial. Okay. Let me copy the formula or whatever you want. The Pascal triangle, the formula, the Newton formula is summation for k0 to infinity, no, sorry. It's not 0, to m. The combinatory number nk is the coefficient a n minus k times b k. This is the Newton formula. And just in case, the Pascal is 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And we need to the fifth power, so one more is 1, 5, 10, 10, 5, 1. So the coefficient is this in our specific example. Now let me okay. The formula contain, sorry, A and B to the n power. However, in our specific example, A is 2x. This is my A, and this is the B, 3. So when you expand that, it's obvious that the coefficient, the first coefficient is 1, que es invisible, you know. And you put A to the fifth power, A to the fifth power, A to the fifth power is 2x to the multiplication by B to the 0 power, because K is 0. So we have nothing. You have you want to put it like that, but this is stupid. No, it's okay. It's okay. At least the first example to understand more clear. Plus the second coefficient Fi. And you put A, in our example is 2x to the 4 power and 3 to the 1 power. It's very, very important to understand it when you're adding the exponent. 4 plus 1 is 5. 5 plus 0 is 5. This is the super fantastic way to verification. What is the next? The next is 10. Entonces 10, coefficient, 2x to the third power, and 3 to the second power. Plus, let me continue here. Bam, bam, bam. Bam, bam, bam. Continuation. Plus, next is 10, no? 10 again, right? 10 again, repetition. 10. 10. So now it's 2x raised to the second power and 3 raised to the cubic power. Because you see how the exponent for the A decreasing and the exponent for the B increasing. Plus 5 is the next guy. Coefficient is 5. 2x to the 1 power, okay, it's invisible 1, and 3 to the 4 power. Finally, 1 coefficient is invisible again is A to the 0 power, because in the last n equal k is 0 exponent. And so no A, no 2x anymore. Now it's 3, just 3. Well, you want to put 1 here, times 2x to the 0 power, this is 1, times 3 to the 5th power. Okay. Well, the rest is arithmetic. 2 to the 5th power is 32. Plus. Entonces es 2 to the 4th power 16 times 3 times 5. 240. 240 x to the 4th power, ¿no? Plus, well, I want to copy directly the answer. 720 x to the cubic, 1080 x to the second, 810 x plus 240. 3. It's the final answer. Any question? Do you understand the idea for the formula of the Newton? We can use in factorial, we can use in combinatory number, or whatever. I prefer the Pascal. What is the disadvantage of the Pascal? Suppose que the power is 20. Oh, this is too long, the Pascal. And we can use the formula for the combinatory number. Any question, guys? Any question? Yeah, me say I understand. And the rest understand? Sean? Now let me see. Betancourt, it's okay. Lustin, it's okay. Karen? Sean? Good. Okay. Super. You say please. Please what? Now let me see what is the please. Sean, you say please? No. Okay. Okay, one more example. One more, no. We are doing the review for this. Way to delete the board. Okay, I waited. Don't worry. Take your time. We have time, guys. We have time to understand everything perfectly. 100%. You help me? And I can try, no? Okay, and done. Okay. Let's move on to the 18. 18 now. 18 is easy, but bring me new situation. W, okay, W minus S. This is S, not 5, to the 6th power. Well, entonces the coefficients, I erased the Pascal, but I remember que the last row of the Pascal that we are doing, 5 is 1, 5, 10, 10, 5, and 1. This is for M5. For N6 would be 5, 5, 5. Wait, 5. For N6 would be 1, 6, 15, 20, 15, 6, and 1. This is for N6. This is the collection of the coefficients in the book. Okay, entonces, professor, but wait, I don't understand something. You explain me A plus B to the n power Newton formula. But what is the formula for the A minus B to the n power? It's the same formula. The only is que the consideration is que B, o sea, instead of B, you suppose in the formula minus B to the corresponding power. So, for example, in this case, the coefficient is 1. It's invisible. And you put W to the 6th power. This is the first guy. This is interesting. And the last guy is X. When I finish the chain, the last guy is obvious que es S to the 6th power. Pero no, okay. Let's continue step by step. Entonces, next is plus the coefficient S6. W to the 5th power, no? And minus S. You consider que minus S. You consider minus X. So the consideration is que this is W plus minus S to the 6th power. It's alternating. This is to the 1 power, no? The 1 power is invisible. It's alternating when you have minus inside the binomial. The first is positive, the second is negative, the third is positive, and so on. Okay. Okay, what are the next? Well, the next is 15. Plus 15, W4, minus X squared. Wow, those are minus X squared positive. The even exponent of S is positive. The odd exponent of S is negative. Plus, what is the next? 20. 20, W3 minus X cubic. Plus, so we are doing this, now 15 again. 15 W squared and minus X to the 4th power, no? Plus, we did that. Now 6 W1 minus X to the 5th power. And the last one is plus 1, que es invisible, coefficient is S to the 6th power. Actually, it's minus X to the 6th power, no? Well, W is 0 power. Okay, now ready to put the elegant final answer is W6 minus 6 W5 X, because my negative is negative times positive is negative, plus 15 W4 X squared positive, because when it's even exponent is positive, minus 20 W cubic X cubic, plus 15, again, the situation que es even exponent, entonces positive, W2 X4 power minus, because it's the fifth power, so it's negative 6w x to the fifth power, and it's a positive because it's even exponent. Final answer. Any question? Entonces, you are strong, no? You are strong in how we can expand any binomial. It doesn't matter the exponent que es 6 o es 7 o es 10 o es 20 o es 200. I know que es too long, no? But this is the idea. However, I want to complicate a little bit the binomial theorem. For example, instead of expand completely the binomial, no. I want to find the term in one specific position. For example, I have here. Okay, suppose in the review, the question 19 say, using the binomial theorem to find the indicate coefficient of the term. Okay, so this give me 9x plus 6 cubic power. But they want the coefficient of x. Wow, what the hell is that? I don't understand very well this. Okay, when you expand this, I suppose in one moment when you expand this, by the way, it's not too big because it's 4 term. Okay, you can do in that way. You expand, blah, 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 and you select exactly the term que contain x to the 1 power. This is the idea. This is one possibility. Another possibility is you know the formula for the Newton. The Newtons say que the summation, but inside the summation the general is nk raised to the a minus k times bk. Entonces, en our example, A is 9x and B is 6. Okay, in other words, I need to know when the n minus k, que es the exponent associated with the A, que es this, should be 1. In other words, k, you solve for k in order to find exactly what is the position inside when you expand the binomial. Because I know okay, in our specific example, n is 3. Is the exponent, this is the same. The 3 minus k is 1. Okay, 2. In the second position, actually no second position, in the third position. Because remember, the first position in the organization for the Newton is 0 is the first, 1 is the second, and the third is 2. Now the k indicate not exactly the positions, the position minus 1. Okay, now entonces I discover, wow, que es, entonces actually I go to my formula, Newton formula. Newton formula say que the coefficient is combinatory number 3, 1, because n is 3, pero the position is 2, sorry, 2, k is 2. Entonces es 9x, que es a in our example is 9x raised to the, es obvio que es 1, ¿no? This was the idea at the beginning, no? 1, and 6, que es b, raised to the second power, because k is 2. Bueno, combinatory number, we can compute it by factorial or Pascal triangle, either way. Pero supposing one complicated problem, que es not 3, es 30. Entonces, do the Pascal is too hard. Okay, let's do it by the combinatory number, que es 3 factorial, divided by 2 factorial, and 3 minus 2 factorial. This is 3 times 2 factorial, this is 2 factorial, this is 1 factorial. 1 factorial es obvio que es 1, invisible, 2 factorial cancel, this is 3. This is 9x and this is 36. And multiplication of everything is 972x. Okay, entonces I suppose que when you expand this binomial in the position third, que es at k equal to, the element of the term is 972x. Clear or confusing? This is another kind of problem in the practice for the binomial. Not necessarily expand everything, so you don't find specific. And the clue can give me the idea what is the location, what is the the exponent of the x is 1. Si hay identification que A is 9x, que es the only guy que have x, because the other is 6. It's because the exponent a minus 1 minus k is 1. Entonces I recognize que k is 2. And the rest is just plugging in the formula de Newton. That's it. Do you understand or no? Confusing? Come on. Question. Are you sleeping or you are aware? Justin? Okay, follow me. Lauren, it's okay? Lauren, you are sleeping, right? Take a note, okay? Can you? Yeah, of course. Yeah, we are doing a review. I mean, in the review we have 20 questions. 20 is similar. Is you find one specific. Okay, guess the 9. So 20 say. 20 say. Okay, find the ninth term and the expansion of the binomial x plus 3y raised to the 10th power. Okay. I need to find, so we have, okay, how many terms we have in, when you expand this guy, how many terms we have in total? How many terms we expect? Si you suppose que you expand everything, how many does it have? How many? Suppose que you expand this. Bam. How many? How many? 11. Very well. 11. We expect 11. However, my interesting problem is a 9 term. My question is, what is the value for the k associated with the 9 term? Let me repeat the question. The question is, I need to find the term located in the position in the position 9. What is the k value associated with this? Question mark. Remember, we start, this is 0, 1, 2, 3, and the last guy is 10, no? Because actually, in total, we have 11. This is the confusing part. Well, this is easy because, the name is 11. Nature in the 11 row. No. Okay. It's 11, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 term. This is the number of the term. first, second, third, 4, 5, 6, 7, 8, 9, 10, and 11. However, the k value, you know, starts at 0. Entonces, sí es 1 less than, ¿no? Dice 1, dice 2, dice 10. And the position 9, ¿qué es this? I suppose que is 8. Okay, this is the confusing part. And the 9 term is the position 8. So we come back to the formula. The formula for the Newton say is nk multiplication by a minus k, bk. Es, in our specific example, es factorial 10, 8. A es x. Entonces, x to the n minus k, que es 10 minus 8, que es 2. So you understand, this is, in our specific example, n k is 10, and k is 8. And b, que b is 3y, raised to the k, que es a power. Okay? Well, the majority of calculator, we can compute the combinatory number in a statistic part combination, because actually this is the number of combination. But okay, suppose by hand, 10 factorial is, well, 10 factorial over a factorial, 10 minus a factorial, something like that. In the calculator, we can do that. 10 times 9 times a factorial. I expand until you get the big number at the bottom, a factorial, because I know that this and this is cancelled. And this is 10 minus a is 2 factorial, and 2 factorial, I know that 2. 90 divided by 2, 45. That number is 45. 45 x squared, and 3 to the a power, woof, I put in the calculator, it's hard, it's 6,561 y a power. And finally, multiplication 45 times this number, and you get this answer. 29,000, 295,245 x to the second power, and y to the a power. Is the final answer. Any question, guys? So the tricky part is the number, because normally you count from 1. However, Newton formula no. Count from 0. Entonces, the number of k is equal to the number of the position minus 1. That's it. No big deal. Any question? Okay, this is the problem I bring for the binomial theorem. Okay, now let's do it. Why not? See, you have no question, no? Let's do in the problem of the mathematical induction. It's only one in the test. Okay, we move on to the question 16. The question 16 say 16. 2 plus 5 plus 8 plus bam bam bam. This is 2n plus 3. 3n, sorry, minus 1 equal n over 2, 3n plus 1. Proof using mathematical induction. So the statement 1 is at n equal 1. At n equal 1 is 2. And the left hand side is, let me see, 2, 3 times 2 plus 1 divided by 2. This cancel out. No, sorry. Como 2? 1. N equal 1. Let me erase everything. It's 3 times 1 because n is 1 plus 1 divided by 2. 3 times 1 is 4 divided by 2 is, does this cancel? Wait. Hello, what the hell? Look. N is 1. Substitution 1 here. This is elementary. 1/2. N is 1 here and here. 3 times 1 plus 1. 3 times 1 is 3 plus 1 is 4 divided by 2 is 2. 2 equal to is true. Okay. Now assume case S of k is true. So you just copy exactly the same our original expression. Okay, want to prove que es true. Replace n for k. Now I try S of k plus 1. Okay, so I copy exactly the same, except que I include one extra. 3k plus 1 plus, and the extra is k plus 1. Entonces, okay, how do you, okay, you, for example, here, one corner here, I want 3k plus 1 minus 1, no? I replace here this k plus 8k plus 1 is 3k plus 3 minus 1 is 3k plus 2. Okay, actually, entonces 3k plus 2 should be, and replace again k plus 1 is k plus 1 divided by 2. Well, in this case, plus 1, entonces exactly the same, pero plus 1, entonces 4, 3k plus 4. Okay, do you follow me? Or it's completely crazy? ¿Es clear o no? Entonces I assume, I assume that this is true, therefore it's equivalent to say k over 2, 3k plus 1. Entonces I copy down 3k plus 1 plus 3k plus 2. So now there are many ways to manipulate this. However, in my opinion, you condensing using this common denominator, entonces es k 3 plus 2 times 3k plus 2. Okay, distribute the property and combine like that. 3k squared plus k plus 6k plus 4 over 2. Okay, now 3k squared plus 7k plus 4 divided by 2. And stop here. In this moment, there are several ways to prove this. For example, the students that are fun to make a factorization, this trinomial, I need to prove that we come back to this. But in my opinion, multiplication is easier than factorization. So this, you foil here, foil. This is 3k squared, plus 4k, okay, plus 3k, 1 times 3 plus 4. And when you combine like term, 3k squared plus 7k plus 4 divided by 2. And this is completely true. And we finish the proof by mathematical induction. Any question? Any question? So I propose you change a little bit the order. Change a little bit the order. Let's start at the beginning. Question 1, question 2, question 3. And so I did intentionally that part first because it's related with the topic we discussed in Theoretica today, no? Guys, I want to hear opinion. Okay. Opinion. Everything is okay or no? Follow me? Okay. Okay. Let's do question 1. I propose you. The order is not important, no? Let's perfect community because we are doing review, no? Those in the review, I suppose. Okay, you are familiar with everything except details. Okay. Suppose. Okay, day 1, and the question 1. Can you find the center, foci, and vertex of the helix? Okay. 25 x squared plus y squared minus 350x plus 1200 equal to 0. A U identification, que es helix. Wow, music. Because we have something x squared plus something y squared. And plus, both square and plus is helix. This is the clue. And this is expressed obviously in general form, right hand side 0. Right hand side 0. But you, in order to find the vertex, in order to find the foci, in order to find the endpoint of the minor axis, you need to express in standard. To express in standard, I need to complete the square. Complete the square. So the organization for the complete square is you focus it in the x part. And you copy 25 x squared minus 350 x. But I can see that is there common factor que es 25. So you factor out 25, we have x squared and 350 divided by 25 is 14. In order to complete the square, you put a box. Y ahí I manipulate the x part. One similar idea I do in the y part. But y, we have only square, we have no linear. That means that our helix is translate in the x-axis, pero no translate in the y-axis. Entonces es just y square. Y in the right-hand side, bueno, I move minus 1200 plus something, que es the box. Okay, entonces what is the number? What is the magic number I need to plug it in here in order to become like a perfect square trinomial? Well, it's 14, no? 14 divided by 2 square. 49, no? 49. It's magic number. The magic number is 49. I introduce artificially 49 in order to complete the square. Complete the square means that I convert to the perfect square trinomial. And when you introduce artificially 49, actually 49 times 25 is 1,225. Where come from this number? What's the multiplication? 49 times 25. Everyone follow me, guys? Do you understand the idea? Okay, entonces we almost. Okay, we almost. Entonces now I know okay, this is a perfect square trinomial. X minus 7 square plus y square. In the right hand side, subtraction is 25. We almost have the standard form of the conic section or helix in this case. Should be 1 the right hand side. Should be 1 the right hand side. Right hand side should be 1. I know that. Therefore, you divide by 25 whole thing. 25 25, 25, 25. So we have x minus 7 raised to the second power plus y squared over 25 equal 1. Nice. This is the elegant standard form of the equation for the hour elixir. Okay. Awesome. Super. Okay. Now we start working. You use a decimal, H1. Okay, let's do it behind. Definitely it's super easy. Identification, the center. The center of the hour elixir is located at the point 7,0. Because H, remember the formula is x minus H squared over A squared plus y minus k squared over b squared equal 1. Oh, not necessarily in this order. In this case, I realize that a squared is here because the big number, 25, is associated with the y. That means that our elixir look like that. It's vertical elixir. So this is the major axis is parallel of the y-axis, and the minor axis is parallel to x. Because, by the way, A is 5 and B is 1. Okay, let me try to do roughly sketch to understand. Okay, this is my graphic. Okay, and the center is 7,0. 1, 2, 3, 4, 5, 6, 7 here. We have translation in x, and we have no translation in y. And the distance is 5. The distance is 5. So this distance A es 5, and this distance B es 1. Okay, si es 1, entonces my point, my vertex is located 1, 2, 3, 4, 5. Here, this point is the point 7,5 is my first vertex. And likewise, here negative 5 is my second vertex. So the vertex is located at the point 7,5 and 7, negative 5. Okay, 7, negative 5. And the endpoint of the minor axis, the minor axis, the distance es B, que es 1. Entonces B from the center to the right and to the left, this point is 8,0, and this point is 6,0, because B is 1. Entonces the endpoints of minor axis are 8,0 and 6,0. So I suppose that our elixir look like that. Okay. Well, remember, the elixir is a smooth curve. Never look like that. So this corner is impossible. This is look like that. Smooth. And one more information we need. But we need the focus. One of the foci, because in plural we have two foci. To find the foci, I need to find the focal distance. And the focal distance is C. And the focal distance is located, I suppose the focal is always inside the elixir. Look at that here. And one distance que I have no idea from the center, que is C. But the formula is C squared is equal A squared minus B squared. Okay, the formula que I memorize in my mind is for elixir is A squared is equal B squared plus C squared. Because I need to remember that in the elixir A is the big number, not necessarily in the hyperbola. Okay, the C squared is equal to 25 minus 1, que es 24. Therefore, C alone is square root 24. And square root 24 is a rational number, and this is 4.899. 4.899. It's close to 5. So the force is always here close to 5. Okay, entonces the force is located at the point 7, no? 7, que es the x component, comma. Let me write it 24. And here, I make the approximation, the decimal, to have some idea how close or far is located for the vertex. No? And this is 7, negative 2, radical 24. Do you want to do in Desmos? Yes, Jasmine said, of course, professor. Do you receive the link connected with the Desmos script, my Desmos script application? Que es fantastic, no? Let me try to open that. Open that. Okay. Definition, no. Conic yes. Okay, conic section. Okay, let me switch in this share the screen to Desmos. Do you see Desmos now? Do you see? Okay. In our example, h is equal to 7. K is 0. So we have no translation. Okay. However, A is 5. And B is 1. And what is the category for the our elixir? Is horizontal elixir or vertical elixir? ¿Es horizontal o vertical? What is the category? Vertical. Okay, entonces vertical elixir. Look like that. Bam. Look at that. This is our elixir. Center 7.0. Vertex 7.5. 7.5. Endpoint of the minor axis 8.0, 6.0, and the force is close, very close to the vertex. What do you think about the eccentricity of this elixir? Is close to 0 or close to 1? Remember, eccentricity is the parameter. It varies from 0 to 1. In this case, it's close to 0 or it's close to 1. The eccentricity give me some idea how rounded or flat is the elixir. In this case, it's very clear que es totally flat. Not totally, but too much. Now, the eccentricity is almost 1. By the way, the eccentricity is the division C, que es square root 24. I put in my calculator now. Square root 24 C, divided by A is 5, divided by 5. The answer is 0.97, 0.98 approximately. That gives me an idea that this elixir is very flat. Okay. Any question? And the question number 1. Okay, let's do one more. And stop. And we continue. Tuesday is the last day. Okay, we are spending the lectures. Okay. Question 2. Question 2 is find the vertex, focus, and directrix. Because they are talking about parabola. What kind of parabola? Let me see. I don't have idea. Is y minus 3 square is equal 4 x plus 4. This is our equation. It's a parabola, he said. And they want to find everything. Vertex, focus. Remember, the parabola have no center. The reason they have no center because this figure is no open. Curve is closed. We have no center. We have vertex, que es equivalent. Pero you identification. What kind of parabola? Bueno, okay. Let me copy the formula. The formula is y minus k squared is equal to 4p x minus h. This is the formula. And you state relationship between this and this. Es obvio que the vertex of this parabola is located at the point, so h is negative 4, opposite sign, and k is positive 3. The vertex is located at the point negative 4, 3. Okay, this is the vertex. Okay. What kind? Remember, I don't see the. Oh, sorry, carajo. Sorry, Karen. Okay, there you go. I see. You see? You see now? Karen? Karen? Yeah. No? Wow. And Jasmine, you see the whiteboard? Okay, I fixed that. Oh, I try. Sometimes work. If I stop sharing, not sharing anymore, and open the whiteboard, and we connecting again the screen of the whiteboard. Let me try. Boom. Karen, it's okay now or no? Yes. Okay, Karen, I am explaining. Bueno, this is the example, ¿no? Entonces, yo identification que es parábola. How do you recognize que es parábola? Remember, the parabola, we have 4 possibilities, no? But basically, y is square and x no square. Or x is square and y no square. Si both are square, bueno, es elipse o hyperbola. Depende si sign es positive o negative. But in this case, one is square and another is linear. Entonces, parábola. Ahora, what kind of parabola it is? What kind? Bueno, the vertex, look, compare this equation and this equation. Es obvio que k es 3 positive and h is negative 4. This is the vertex. But this parabola, when the y is square and x is square, is horizontal parabola. And this is a vertical parabola. So we are in front one typical example of the horizontal parabola because y is square and x is not square. So how do you know in what direction open? Well, depending on the p sign. I know that 4 is equal to 4p. Compare this equation. Therefore, p is 1. You see, p is 1. This parabola open to the right. Bam, like that. And the vertex is this point. Make sense? Okay. P is 1. Okay, let me try to do roughly sketch first. And after we are doing Desmos. I open in the left. When it's negative, yeah. Okay. Yes. The answer is yes. Okay, we have horizontal parabola or vertical parabola. Look, look. Positive. Horizontal, P negative. Vertical, P positive, up. Vertical, down, P negative. Horizontal parabola, vertical parabola. You need to know this concept. Okay, our parabola P is not 1, it's positive, no? Therefore, is. Okay, the vertex is located at the point negative 4, 3. Negative 1, negative 2, negative 3, negative 4, 3. Positive 1, 2, and 3. This is the y-axis, this is the vertex. I know que our parabola open out in that direction. But no, I don't want to do a crazy like that. Because remember, the quantity can give me information how open or narrow or wider or narrow our parabola. No, never is like that. It's like that. Depending the focal diameter. The focal diameter distance. Okay? Entonces now, you know, okay, open in that direction. I have no, see wider or narrow. But the focus is located P distant for the vertex in the same direction. So always the focus lie inside the parabola. S1, entonces my focus lie here. At the point que I suppose que es negative 3, 3. This point was the vertex negative 4, 3. The focal diameter is, well, the focal diameter is 4p. 4p is focal diameter. Actually 4. And the semi-focal diameter is 2. So from the focus to upward and to downward. Entonces es en phi, ¿no? En phi, here. 4, 5, 2. At this point is the point negative 3,5. This is one end point of the focal diameter. And down to is in 1. 1 here. This point is the point negative 3,1, no? Okay, this is, what is this guy? Endpoint focal diameter. Entonces, my parabola, more clear now, look like that. Ooh. Okay, smooth. Let me try to do my best with the pen. Okay, the focus here. And the endpoint focal diameter is this guy and this guy. That's it? No. I need the axial symmetry. Axial symmetry. Okay, let me erase that part. Okay, axial symmetry. It's in this case horizontal line passing through the vertex. I suppose que es blue color. And the equation is y equal 3. And we have the directrix, extremely important, directrix. It's a vertical line in this case because it's horizontal. We are talking about horizontal. And from the vertex, the same distance of the focus, P and P in another direction. Bam, bam. Bam, 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 bam. This is x equal, and the equation for the directrix, is negative 5. Okay, the equation for the directrix is x equal negative 5. X equal negative 5. And that's it. Okay, what is the information that we need? We need vertex, we need focus, we need the endpoint for the focal diameter. The focal diameter, this total distance focal diameter is 4. This distance is 4. Okay, we split 2 upward and 2 downward from the focus. That's it. Okay, entonces let's do an decimal and end the story for today. You have question or no? Okay, this is no big deal. This is no complicated. The only problem is that we have a lot of terminology and you need to organize to understand. So I like so much the geometry interpretation. No, you see the picture, it's much better. Definition, formula. No, not good. Let's go moving on to Desmos. Let me know when you see Desmos. Okay, that was example. Elixir, no Elixir anymore. No. It's parabola. Okay, Sean, thank you. Okay, this is our parabola. What kind of parabola? Is it horizontal parabola or vertical? Okay, well, okay. Entonces, en parábola, have no sense to talk about A and B, no. It's H, K, and P. That's it. H, in our example, is -4. K, in our example, is 3. P, in our example, is +1. And I categorization like a horizontal hyperbola, no, parabola. Horizontal parabola. Bang. Something like that. Okay. And you can see the vertex is located at the point, -4,3. The focus is located -3,3 positive. The endpoint for the focal diameter, -3,5 and -3,1. The axial symmetry is the line y = 3, and the directrix is the line x = -5. Any question? Wow, we are the best. Really or no? Yes, absolutely. So, guys, take advantage. You have a lot of work to finish with me. Okay, remember you need to completion the homeworks. G1 extra credit, no? And entonces take the pre-test to be strong. And when you are strong, take the test 2 times as always. Test online is due. Test number 5 online is due the same day, April 28. And on paper you send by email as always. And we continue then. We continue next Tuesday, and that's it. Okay, take care. You too.